All right, welcome to The Explainer. Today, we're diving into a breakthrough that makes AI assistants not just a little bit better, but potentially like orders of magnitude more powerful. Let's break down how one simple change in thinking can unlock a whole new level of AI efficiency. So here's the big question, right? It's not just about making an AI smarter. It's about making it faster, cheaper, and way more capable of handling messy, real-world tasks without getting totally bogged down. So how on earth do you get that kind of massive leap in efficiency? Well, the answer starts with something called tools. You can think of these as little special apps that an AI like Claude can use. One tool might search the web, another one might pull data from a database, a third could run a piece of code. Basically, they're the AI's hands and eyes for getting things done. But how the AI uses them, that makes all the difference. And that brings us right to the core problem, the big bottleneck. See, for a long time, the way AI models use these powerful tools had this major, kind of hidden flaw that made even simple-sounding tasks incredibly slow and expensive. And this analogy just nails it perfectly. Imagine a manager who needs a report, but instead of just asking for the final report, they ask their assistant for a single number. Then they stop, have a whole meeting just to think about that one number. Then they ask for the next number, have another meeting. You get the idea. It's painfully slow, and honestly, that's exactly how AI has been working until now. Let's actually walk through what that looks like. It's this constant, painful back and forth. The AI makes a request, gets a tiny piece of info, pauses to think, then it has to make another request. Every single one of these is a full round trip between the AI's brain and the tool. So if you need to check 20 things, you're doing this whole dance 20 separate times. And, the consequences of this are huge. In the tech world, they call it high latency, which is really just a fancy word for delay. It makes the whole process feel slow. It also racks up really high token costs. And since tokens are basically the building blocks of an AI's thinking, this is like making the AI do an insane amount of expensive work for a really simple job. Okay, so how do you fix this mess? Well, you teach the AI to stop being a micromanager and start acting like a programmer. And this is the game-changing solution we're talking about today, Programmatic Tool Calling. So here is the key idea. Instead of asking for stuff one by one, Claude now literally writes a small piece of code, a little Python script, that lays out the entire plan from the start. This script then goes off, calls all the tools it needs, does the number crunching, and only then does it come back to the main AI brain with the final summarized answer. And when you put these two methods side by side, wow, the difference is just night and day. The old way is slow, it's sequential, it's expensive, and it clogs up the AI's precious memory, its thinking space, with tons of raw data. This new programmatic way, it's fast, it's cheap, it's efficient, because only the final important result ever makes it back to the AI. All right, so let's pop the hood for a second and see how this actually works. And don't worry, we're going to keep this super simple, no heavy jargon. Okay, so it really just comes down to these 4 steps. First, Claude looks at the task and writes a script. That's its plan of attack. Second, that script gets sent off to run in a totally safe, isolated environment, kind of like a separate workshop. Third, inside that workshop, the script does all the heavy lifting. It calls the tools, grabs the data, does all the busy work. And finally, step 4, only the clean final answer gets sent back to Claude. And this right here, this is the magic trick. It's absolutely crucial. All of that messy intermediate stuff, all the raw numbers and lines of code from the tools, it never even touches the AI's main thinking space. This keeps the AI focused, it keeps its memory clean, and that's what lets it tackle even bigger, more complex problems down the line. Okay, so this all sounds great in theory, right? But what does it actually mean in the real world? Let's look at a concrete example straight from the developers at Anthropic, because it really shows the night and day difference this makes. So here's the task. Imagine you need to check the expense reports for 20 different employees to see if anyone went over budget. It's a pretty simple but definitely repetitive job. Now, the old way, the AI would have to make 20 separate round trips. That's one call for each and every employee. It would have to pull in all their data, think about it, then move on to the next person. So inefficient. But with this new programmatic way, just one. That's it. One call. The AI writes a single script that just loops through all 20 employees, checks their budgets, filters the results, and hands back a simple little list of only the employees who were over budget. Going from 20 interactions down to just one, I mean, that is a massive, massive leap in efficiency. And that kind of efficiency boost, well, it unlocks a whole universe of new capabilities. All of a sudden, the AI can analyze huge data sets almost instantly. It can run these complicated, multi-stepped research projects. It can make smart decisions based on the data it finds along the way. It can batch process thousands of items at once, or take a literal mountain of data and filter it down to a single, simple insight. These are all things that were basically impossible before. So let's zoom out for a second. What's the really big picture here? Because this isn't just about making things a little faster. No, this is a foundational step toward creating truly autonomous AI agents, AIs that can actually handle complex, multi-step goals all on their own. Just take a look at this chart. When you test an AI on really complex research tasks, tests that see how well it can do deep, multi-step information finding, an AI with just basic tools does, okay. But when you add this one feature, programmatic calling, the researchers said it was the key factor that fully unlocked agent performance. The performance just skyrockets. It really all boils down to this one fundamental shift. We're moving away from an AI that has to kind of talk its way through a problem, loading every single detail into its short-term memory, and we're moving toward an AI that can work its way through a problem, using code to do all the heavy lifting behind the scenes. And that really leaves us with a pretty mind-bending final thought, doesn't it? We've basically given the AI the ability to think and reason like a programmer, to create its own little workflows on the fly to solve problems way more efficiently. So the question we're left with is, what are the new limits? When an AI can write its own code to get a job done, what problems are we going to see it solve next?